All right, so welcome to another episode. In this one, we'll be talking about our exponential search. So, the exponential search works pretty simple. The step by step process is start with a small range, then expand the range exponentially, and then perform the binary search. Simple as that. That's just three simple steps. You have to start with a small range, then you have to expand the range exponentially, increase the range by doubling the index until the element at the index exceeds the target or index surpasses the array length. Basically, this is how it works. And then you have to perform the binary search, the last thing. That once the potential range is identified from, let's just say, last power of 2 to the current index, perform the binary search within that range to find the exact position of the target. Right? So the complexity is the time complexity, best range, best case, average case, and the worst case. So the best case is if element is found at the beginning. Average case is if where the I is the position of the target element, and worst case is where n is the size of the array. And then there is space complexity, which is as it is only requires a constant amount of extra space. So basically what we're going to do is just to do the binary search, which we have already studied. So there is nothing to like describe in it. There's nothing to explain in it. You can just go on to the playlist and you can search and you can find the binary search. So once we're done with the binary search, it's basically one of the most simplest searching algorithms, not one of the most. This is one of the only most easiest searching algorithm ever I've seen or learned. So once we're done with the binary search algorithm, we'll move on to the exponential searching algorithm. So basically what we're going to do, I'll give you a brief explanation, is start by checking if the target is at the first index. If yes, then return 0. So let's just say if it's on the first position, then we'll return 0. Then what we're going to do, the next thing is initialize, right? So let's just do the first thing, return 0. That's it. And then what we're going to do is initialize I is equal to 1 and double I repeatedly until array of I exceeds the target or I surpasses the array length. So how do we actually do that is I is equal to 1 and then while loop while while length of array is greater than I and target is greater than equals to array of I. If not if this condition, until this condition is true, I multiply equals to 2. That's how it's going to be. And then return the binary search, where we are going to do the binary search stuff. So we pass on all the stuff which is left, right, and the target. And once we're done with that, we are now good to go. Right? So perform the binary search within the range of 1 by 2 and minimum of I comma length of the array minus 1, and then to find the exact position of the target. That's it. So let's just create the array, and as I said, it has to be in a sorted format. If it's not sorted, it's not gonna give you any fucking output that you desire. You have to sort it in order to get a proper output. All right. So once you're done with that, you will just simply create our target. And first, let's just create a little bit longer. It's gonna be fun. So let's just say now the target is going to be 56, and then let's just say our old school stuff. If index blah 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 does not equals to -1, if index does not equals to -1, which means it returns something, and if it returns something, then what does it return? So it returns target and index. So let's just print the target and index. Okay, we're doing pretty fine. Oh right, we forgot to mention the index part. So index is equal to exponential search, and inside of that we're going to pass our array and target. So what we're going to do is element and inside of the parenthesis target and found at index target. No, sorry, index. All right. Okay, and then else part, print element target not found in the array. Or let's just say not found. Simple as that. We're not going to do like too much of crazy nonsense. Then let's just say python 15.py and boom, it says not found. Why does it say it's not found? Because the array is not sorted. So what we have to do is basically sort the list. This is where we lack. We have to sort the list. We have to have a sorted list. So if I were to say another list, let's just say 3, 5, 7, then let's just simply put on some elements which is in a sorted format, ascending order. And if I were to use this ascending order, then I am 100% of likely to get the desired output, which is finding the element. So now I have perfectly sorted array, or let's just say list. So now let me just run this and you can see 56 found at the element at index 11. That's how it works.